Hello coders and developers. Welcome to gilgeekify programming. I'm Saeed Kohansel, your guide on this exciting journey through the world of full-stack web development. Let's dive in and start creating something amazing together. In this video, you'll learn how to build cross-platform desktop applications using Electron.js, Node.js, and JavaScript. We'll cover packaging your app with Electron Packager and NPM, creating one-click installers with Electron Installer, and making a portable version with Enigma Virtual Box. This tutorial is perfect for both beginners and experienced developers. Don't forget to like, comment, and subscribe for more tutorials. First, let me show you a demo of the application I have created. It is a web application for generating various types of passwords, which I have named Safe Password Generator. Let's review it a bit. This app is ready to use, and I intend to convert this web app to an Electron.js app in this video. So far, we have been viewing the app in the Google Chrome browser. This is the Electron version of the app that we are going to build together, which runs with Chromium and Node.js. When I click the Generate and Copy button, the app creates a new password according to the above settings and automatically copies it to my clipboard. Also, if I press the Enter key, the same action is performed. I have placed an option here so that when you click on it, the dev tools will open for you. This works exactly like the inspect element in Google Chrome. For debugging purposes, I have defined console logs in the password generation process to monitor events within the app. Also, when you right-click inside the app window, you will see the options I have defined with the specified icons and actions. Please note that all the tools I use in this video are completely free. I will provide all the necessary links in the description. I am using the Windows operating system, and you can adapt the methods based on your own operating system. To install and run Electron projects, we first need to install the prerequisites, which are Node.js and NPM. To install Node.js, visit its website and download and install it based on your operating system. You can also use a package manager for installation, such as NVM. I have installed Node on my system, so in this step, I will install NPM. To install NPM, simply run this command in your terminal to install it globally. Very good, NPM was successfully installed. Let's check the version of Node and NPM. So far, I have both Node and NPM installed on my system. We have installed the prerequisites. Now it's time to create an Electron.js project. I have my web app here in HTML, CSS, and JavaScript as a web-based application. I create a folder with a desired name. I name it SPG Electron App. Now, I open VS Code and run cmd in the path of this folder. Okay, now by running this command, I am initializing an npm package. Alright, now by using this command, I am installing Electron locally. Okay, Electron has been successfully installed, and as you can see, it is listed as dev dependencies. Let me modify the package specifications a bit. Note that to execute Electron, you need to configure the scripts like this. Then I add main.js. The entry point of any Electron application is its main script. This script controls the main process, which runs in a full Node.js environment and is responsible for controlling your app's lifecycle, displaying native interfaces, performing privileged operations, and managing renderer processes, and more. I'm going to paste a script that I have written for my Electron app here. In Electron, the main window.loadFile method is used to load local HTML files. However, if you want to load an external URL in your Electron app, you should use main window.loadURL instead. Let me add the program files. Okay, now to run the app, we execute the command npm start. Alright, as you can see, the app was successfully executed. And it works correctly as well. Let me introduce you to the Electron environment and how it works. Here is a repository you can use to help you get started. In general, Electron operates with 4 main files, which are package.json, preload.js, main.js, and renderer.js. Their functionality is explained on this page. I recommend checking the official Electron documentation for a better understanding. Let me explain the files of my project. You can download my source code and read the comments within the code. The file, app.js, is where I have defined the operations related to the safe password generator application. Inside the renderer.js file, we define our desired actions, which are then sent to preload.js. The preload script runs before the renderer process is loaded and has access to both the renderer globals, e.g., window and document, in the Node.js environment. I have embedded the app.js and renderer.js scripts in the HTML file, and logically, both of these scripts are considered as renderers. They can interact with preload.js. Let me show you a few examples. For instance, this part of the code makes the DevTools open when the user clicks on the desired link or button. Or, for example, this part of the code makes the app window close. In fact, the command is sent from the renderer file to the preload file, where the action is executed. And similarly, we execute some actions within the main.js file. So, we have become familiar with how the Electron environment works and how the files interact. As you can see, I have defined a custom context menu with a name, icon, and specific actions. You can also customize this according to your needs. Alright, since I've already designed and prepared the app, let's move on to packaging it. To do this, I'm using Electron Packager. Electron Packager is a command line tool and Node.js library that bundles Electron-based application source code with a renamed Electron executable and supporting files into folders ready for distribution. For better understanding, you can refer to the Electron Packager documentation. There are many options and variables available that you can use. Alright, to install this library, simply run this command in your terminal. Great! As you can see, the tool has been successfully installed. Now, I'll write a command to build a package for Windows 64-bit with a custom icon. Okay, I'll try to explain each part of the command in detail as I write it. npx is a package runner tool that comes with npm Node Package Manager. It allows you to run commands from npm packages without globally installing them. At Electron/Packager is the Electron Packager module. It packages Electron apps for different platforms. The dot character specifies the current directory as the source of the Electron app. Safe password generator is the name of your application. Platform Win32 specifies the target platform for the package. In this case, Win32 means Windows. Arch-x64 specifies the architecture of the target platform. x64 means 64-bit architecture. Outdist specifies the output directory where the packaged app will be placed. In this case, it's the dist directory. Icon specifies the path to the icon file for the application. This is the icon I designed for the application, which is located in this path within the program files. And lastly, the overwrite flag tells the packager to overwrite any existing output directory. Now let's run this command. Excellent. As you can see, a new package has been created in a folder named dist. Let's review and run this application. The total package size is 266 megabytes. Here you can see the program files and resources. And this is the executable file of the app. Let's test it. As you can see, the application runs correctly and works. In this step, I want to output another version of the app with the ASAR flag enabled. This flag helps mitigate issues around long path names on Windows, slightly speeds up require, and conceals your source code from cursory inspection. The ASAR version of the app has been generated. Let's compare them. Here we have two versions of our application, one is ASAR and the other is the normal version. In the normal version, the program's resources and files are accessible and even editable by the user. However, the ASAR version requires a tool called Electron/ASAR to open and edit. It is also worth mentioning that, in general, for the app to run properly, the resources folder should contain a folder named app with the necessary contents, or a file named app.asar. So, in this section, we have learned how to package and prepare the application for distribution. Now, in this step, I want to teach you how to create a one-click installer for an Electron application. I use Electron Installer, which is an NPM module that builds Windows installers for Electron apps using Squirrel. Squirrel is an installation and update framework for Windows desktop apps. To create the installer using this module, you need to write a script and configure it according to the variables provided in the documentation. As usual, let's start by installing this module using this command. Alright, as you can see, Electron Winstaller has been successfully installed. As I mentioned, to create the installer file, we need to write a script. I will create a script named create-installer.js. Before we start, let me combine the ASAR version and the normal version to see if it works correctly, as I mentioned a few minutes ago. Now, let's test it. Yes, as you can see, the application works correctly even though we completely changed the contents of the resources folder. Very well, so we now have an application ready for release and distribution, which is also ASAR packed. Okay, now it's time to write the script. I import the necessary modules from the Electron Installer package and the path module for path manipulation. I define an asynchronous function to create the Windows installer. I await the completion of the Create Windows Installer function with specified options. I specify the path to the directory containing the packaged app. I determine the path to the directory where the installer will be saved. I specify the author of the application. I specify the name of the installer executable. I determine the name of the application executable. This name must exactly match the main executable file of the app that is in the package. I write the description of the installer. I determine the version of the installer. I specify the path to the loading GIF displayed during installation. Now, I will specify the icon for the application installer. Setup icon is the icon designated for the installer file itself. Icon URL is the icon that appears in the Uninstall a Program section of the Windows control panel when the app is installed. I disable the creation of an MSI installer. I log a success message to the console if the installer is created successfully. I log an error message to the console if there's an issue creating the installer. Alright, our script for generating the installer file is ready. Now, I need to call the function. I call the createInstaller function to start the installer creation process. Okay, in this step, I just need to run the script to create the installer file. To run the script, simply type node followed by a space and the script file name, then press enter. Perfect, as you can see, the success message we defined in the program has appeared, so the installer file has been successfully built. As we defined, a folder named installer has been created, and the installer file is inside this folder. The generated installer file is 107 megabytes in size. The application is ready to be installed. Let's install the app using this installer file. That's awesome! Our app was successfully installed and launched with just one click. And as you can see, it works correctly. Let me show you where the app is installed. Yes, the app files are located in this path. Now, I will create a shortcut for our app on the desktop. So, our application is installed in this folder and path. Let's take a look at the files. Since the app is installed on our system, if we go to the Uninstall a Program section in the Windows Control Panel, this app should be listed there. I will show you this later. Let's test the app again. So, in this part of the video, we successfully created an one-click installer file for our application. Alright, as the final part of this video, I want to show you how to create a portable version of our application using Enigma Virtual Box. Let me tidy up the desktop a bit first. I want to separate the different versions of the application we have developed and place them side by side. Alright, let's start building the portable version of our app. To do this, open the Enigma Virtual Box software. I will definitely provide the download link for this software in the description of this video. First, select the main executable file of your application as the input. Good. Note that we are using the packaged version of our application to create the portable version. Now, enter the application folder and select all files and folders except the main exe file. Then, just click OK. Go to Files Options and check the Compress Files option. This will significantly reduce the size of the final file. Finally, just click the Process button. Excellent, just like that, we've created a portable version of our application. This executable file is actually the portable version of the app. Let me tidy it up and rename it. Let's test and run it. Great, the portable version of the application is working correctly and as expected. Now, let's do a size comparison between these three versions of the app. Sorry, let me delete the extra files to determine the actual size of the packaged version. Alright, the packaged version is 266 megabytes, the installable version is 107 megabytes, and the portable version is 217 megabytes. So, the installable version has the smallest size. Okay, as a final test, let's open all three versions of the application side by side. Perfect, everything is working correctly. So, in this video, we learned how to create an application using Electron and JavaScript. The last thing I want to show you is uninstalling the installable version of the app. As I mentioned earlier, when you install the installable version, it gets listed in the Uninstall a Program section of your Windows control panel. You can remove the application from your system with a single click. The uninstallation process is as simple as the installation, done with just one click. If you found this video helpful or enjoyable, please give it a thumbs up. To stay updated with my latest content, make sure to subscribe and hit the notification bell. I value your thoughts and feedback, so don't hesitate to leave a comment. Thank you for watching, and I hope you found this video beneficial.
Because I will not quit, not because I want this.